So as winter is spreading now, you can see that the cases are on rise. So I hope that you all are safe and protect yourself. So please follow the advisory of the state government and the precautions which school has told you to take. So now, children, last time what you people have studied? Class 11th, Lavanya. But okay, so and rest of you, please. I hope you all have watched the video. If by mistake you miss the class, how many of you have watched the video? I'm talking about class recording. Kartikeya Pandey. Beta, have you seen that video? Tell me. Udbhav Agarwal. Why? The class recording is very much there. Sushmita. Beta, have you seen that video? You attended the class. Good. And कौस्तो ये कौन है हर्ष चौहान आयुषी वत्स मेहुल सिंह मयंक सिंह you all attended the class last time. Okay, so any problem in that, in any of the concept? Okay, so I will discuss, but not today. Today I'm just going to start with gates, and after that the things which are left I will discuss later on. Okay, now I'm just going to start the class. So first of all, children, I would like to tell you what is gate. What is gate, children? Please tell. Anybody? If can. Lavanya, do you know anything about gate? Beta, gate is the smallest electronic circuit to carry binary signal. Right? What is gate? I'm just talking about logic gate. So gate is the smallest electronic circuit to carry binary signal. And these gates are of two types. The first type of gate is basic gate, and another type is universal gate. So universal gate, actually there are only three gates which are basic gates, but universal gates are actually the alternative of basic gates. And the benefit with this universal gate is that using this, okay, but screen is, I am presenting my screen. I am now going to represent. Is the screen visible now? So you need to reconnect. Kaustubh. Anybody who is not able to see the screen, please tell. Rest of you are able to see the screen, please tell. Okay. So basic gate and universal gate. So children, universal gate is the gate with the help of which we can implement the functionality of all the basic gates. basically why gates. Actually, children, if you see the motherboard of your PC, the circuits which are made basically are gates. All are gates. And these are made up of silicon chips. Silicon material is most suitable for these gates, and that's why very costly. So further, if we classify these gates, these basic gates are of, these are of three types. So the first one is AND, OR, and NOT. These are the basic gates. And if we talk about universal gates, these are of two types. The first one is NAND, and second one is NOR. These are the universal gates. So before I will start with the basic gates, let me teach you what are minterms and maxterms. So anybody if knows about minterm and maxterm, please tell. Children, do you know about minterm? Okay. Kaustubh, are you there now? Cost, now screen is visible or not? Okay, so whenever such problem comes, it simply means the problem is at your end just because of network. So sometimes you need to reinitialize the network. So reinitializing means it doesn't mean that start the modem again. No, just reconnect. Okay, so that's why the technology is also not 100% reliable. Okay, so now here I'm just going to tell you about maxterm and minterm. So children, if you see here, children, here I have taken two constants, and the first constant is A. The first constant is A and second constant is B. And here I am just writing minterm. This column is for minterm, and one more column I am going to draw, and that is for maxterm. So children, since there are two inputs A and B, so total number of combinations will be 4. So here now what you can do is, children, here it is 0, 0, 0, 0, 1, 1, 0, and 1, 1. So these are the 4 combinations. So now I'm talking about minterm. Suppose any two values I'm picking here. Here it is minterm. So actually just write minterm is the product of all the literals within the logic system. So all of you please write. Minterm is the product of all the literals within so minterm is the product of all the literals within the logic system, and where maxterm is the sum of all the literals within the logic system. So it is minterm and maxterm. So now here the second column for the maxterm, which is maxterm. So this is maxterm. So suppose children I am picking the very first this one. I am selecting a particular cell. So here the value will be A complement B, since it is the product of all the literals. So in front of A you can see that 0 is there. If we talk about this cross section, if we talk about this cell, this row, if we talk about, so the values are what? It is 0 means A complement. You just see this, 0 means A complement and 1 means B. That's why I am writing here A complement B. And in a similar way, suppose I am picking this one here, this one. So here it is AB, because both the entries are 1. If I am picking this one, this very first one, it will be A complement B complement. Why multiplication? Because minterm is the product of all the literals within the logic system. Since minterm is the product, that's why it is. Any issues, then please tell. Yes. 0 is always represented as complement in minterm. Okay. And now here max term. So for max term, what you can write is, here you can write A plus B. Since max term is the sum of all the literals within the logic system, that's why it is written as A plus B. And in max term, for 0 we don't write A complement. For 1 we write A complement in max term. Suppose for this particular cell we want to write the max term. So here it will be A complement plus B. And for here it is A complement plus B complement. If still you people have any issue, then please tell. In a similar way, we can draw the truth table for 3 variables also. So if you have any doubt, then please tell. Class 11th. Class 11th. Lavanya. Lavanya, Sushmitha. Because maximum and minterms are complement of each other. So if it is 0, then it is 1. So it simply means in minterm, if we have considered 0 as complement, it simply means that in maxterm we are going to consider 1 as complement. So later on you will get to know more about minterm and maxterm, but just now, till now, this is the concept. Okay. But there is one more thing associated, which is gray code, that I will tell you later on. But till now, I hope you all have understood how to write minterm and maxterm values. class 11th, Kaustubh Agarwal. Now one more thing, children, any valid Boolean expression, a valid Boolean expression can be represented either in max term only or min term. Any valid Boolean expression can be represented by either max term or min term. We cannot combine both these terms together. Okay, so here the expression, the Boolean expression which is made up of only min terms is known as SOP expression. That is sum of products. That is SOP expression. So here if I am considering the three entries, A complement B complement plus A complement B plus AB is the valid SOP expression. So there are two type of expressions, either SOP expression or POS. So SOP stands for sum of products, whereas POS stands for product of sums. Now here I am just going to write POS expression. So that POS expression is the multiplication of the max terms. So which is A plus B, A complement plus B, A complement plus B complement. This is the valid POS expression. And both the expressions are complement of each other. But here exactly it is not the complement of each other because two terms are common. देखिए यहाँ पर हम उस चीज को जो बोल गए हैं वो चीज यहाँ पर हम नहीं कर सकते, लेकिन होता है. देखिए, if we are considering min term here, then we will not be considering max term. I was just giving you one example. तो यहां पर ये दोनों चूंकि कॉमन हो गए, इस वजह से ये प्रॉपर्टी फॉलो नहीं होगी. अदरवाइज SOP and POS are the complement of each other. That I will tell you and explain you also. Yes. बेटा कॉमन का मतलब है कि हमने दोनों को कंसिडर कर लिया. मतलब द पर्टिकुलर सेल, if we do the proper numbering, here it is 0, here it is 1, here it is 2, and here it is 3. So if the cell 0, row 0 I have considered in min term, then the same cell we will not be considering in the max term. This you have to be very careful. Just wait. It is 0, it is 1, it is 2, and it is 3. So if I have taken this A complement, B complement which represents 0, so the same we cannot take here. So you will get to know later on few more things, don't worry. So this is the simple method of how to write the expression and what are the min term and what are the max terms. If you have not understood what is min term or max term, then please tell. Yes. But I have taken on random basis. This is random basis पे ले लिया है. अब fill भी कर सकते हैं, नहीं भी कर सकते हैं. I have just taken one example, and this example is not having any validity. Don't worry. It is just, I was just teaching you how to write and represent. Okay, so later on you will come to know. Okay, so this is what SOP and POS expression. And there are two more types of expressions, beta. That is, one is canonical, which I have told you just now, and another is cardinal expression. So that I will also explain, but not just now. Okay. So suppose I am writing any expression. So before that, I would like to just explain you what are the basic gates. So children, basic gates are also known as fundamental gates, and these are of three types I have just told you: and, or, and not. So first of all, let us see what is and. हाँ हाँ तो ठीक है, no issues. And is what? Tell Kaustubh, what is and? Yes, and you know the truth table also. Got it? And you know the symbol also, right? Okay, so I'm not going to explain this. Okay, well. Now one more thing is OR gate. You all know OR gate? What is OR? Anybody please explain? Please explain what is OR gate. OR is the huh. Very good. Yes, and not does complement. Got it? Okay. Now further is what I'm just going to write an expression, and this expression is suppose z is equals to, yes, not is a gate which does complement of the input. Okay, if 0 is there, then it is 1, and if 1 is there, then it becomes 0. Okay, so here a complement b c plus a b complement c plus a complement b complement c plus abc. Children, this expression is what? SOP expression, right? Why SOP expression? Because all the midterms we have considered, all the midterms, and the midterms have been added. Okay, now what is the purpose of what I'm going to tell you? I'm just going to teach you how to draw the circuit diagram using this. So let us draw the diagram. So first of all, this line here. Why I am drawing these three lines? Because there are three literals A, B, C. Got it? And this one is the NOT gate. This one is the NOT gate. And why NOT gate? I'm just drawing the here line. I will tell you what is the meaning of these lines also. Now children, here one important thing is that this is representing A, this is representing B, and this is representing C. So please concentrate. If this is A, then it simply means with this not it is A complement, right? If any confusion, then please tell. This in SOP expression, beta, we consider minterms, and if you want to represent minterm, you have to take complement. I have not told that you cannot take whatever you are saying. Both 0 and 1 we can take in SOP and POS both, but representation is different. Here I'm not telling what is coming, I'm just telling you that if A is coming along this wire, then definitely A complement is coming along this wire, because we are using NOT gate. And what NOT does, it does the complement. That's why this is what I was telling. In a similar way, if B is coming along this wire, then definitely B complement is coming along this wire. So that is B complement. And if C is coming along this wire, then definitely C complement is coming along this wire. If you have any issue, then please tell. Kaustubh, hurry up, beta, please respond. Okay, now. Yes, it is a circuit diagram. One more thing. Children, the terms which we have connected are what? These are min terms, right? And min terms are what? Logical multiplication. So with the help of which gate you can represent min terms? With the help of AND gate. So how many min terms are there? There are 4 min terms. That's why there are 4 AND gates. And now I am going to connect A complement BC. Means that this A complement will go directly and will get associated with this line. Second is B. So it is very simple. B also will get connected with this. And then it is C. So C also will get connected with this. So the first gate, which is AND, is representing A complement BC, and here A complement BC as a output is coming outside. So by definition, AND is a gate which receives 2 or more inputs. So here I am passing 3 inputs. I am passing A complement B and C. So it gives the logical multiplication of these 3 complements, which is A complement BC. In a similar way, connect all the wires. Second is AB complement C. So second is A. This is A, and now here it is B. Uh, Second is B complement, okay, and the third is C. I have connected. Now the third gate, it is A complement. So no issues. It is A complement. Then it is B complement, okay, and then finally it is C. Third one is ABC. So here A is coming like this, B is coming like this, and C is also coming like this. So children, I have connected all the gates. And now how these min terms are associated. Children, these min terms are being added. And which gate represents logical addition? That is OR gate. So here one more gate will come, which is this one, and here. So now connect all these. The first, बेटा यहाँ पे थोड़ा सा आपको देखना पड़ेगा, वायर का दिक्कत होगी. And here it is the third one. And the fourth one. I have added. And now children, here what is coming, which is capital Z, is coming as output. It's done. This is how you have to draw the circuit diagram. So if anybody has not understood, then please tell. Beta class 11th. Class 11th, if any issue, any problem, then please tell. So children, this is how you can draw the circuit diagram. Vibhor Vash. Vibhor Vash, are you there? Beta, after the class, I want to talk to you. Okay, you wait after the class. Okay. Now, Ayushi was Yasir, Arun Pandey. Anybody, if you have Saksham Kalra, if you people have any doubt, beta, then please tell. Okay, now I'm going to give one more example. And this, the diagram for this, you have to draw your own, all of you. So Z is equals to A, B complement, C complement, plus A complement, B complement, C complement, plus A, B, C. So please draw the logic gate diagram. Hurry up, all of you. Please draw and then either WhatsApp me. Better if you WhatsApp that. Hurry up, children. All of you, please draw that. So first of all, I would like to know that how many minterms are there? Children, please tell how many minterms are there? Okay, so if there are three minterms, it simply means that there will be three AND gates. And now we have to connect. The first one is A, B complement, C complement, so that is A. So just connect the wire from this place and it is A. And second is B complement. Fine, so it is B complement. And the third is C complement. The first gate we got connected. Now for the second gate it is A complement, and here it is B complement, and here it is C complement, and the third is ABC. So A, B and C. So now if you have any doubt, then please tell. And after we have connected these, we need one OR gate. This is the OR gate. Okay. But a WhatsApp, you have on WhatsApp or where? Okay, okay. Checking, beta. Wait. Beta, I have not received. Where you have sent? Okay, now you can check this. What to do is you have to connect this by. So the first is, the second is, method is. And this Z is coming, so it's done. This is how you can draw the circuit diagram. So, but I have not received. On which number? Okay, now I have got. Okay, it's correct. Yes. Ah. Yes, definitely 1 hour we have used. In the previous one, I have used 1 hour. Definitely we can use. I told you that day, na. Actually, in your motherboard, 1 OR or one NAND gate only receives two inputs. If you see this structure of the NAND gate, how many inputs are there? Only two. Only two inputs. But on paper, we can draw the diagram which can receive more inputs, no issues. That is also correct. First of all, two, and then further we can pass. Okay, so any confusion, any issue, then please tell. So children, in last class, Rajiv sir has taught you the Boolean laws or not? Okay, so Lavanya and Shushmita, it's your responsibility to remind me when I'm finished with the gates. Right, I will teach you Boolean laws and your doubts, whatever. Okay, so after first of all, you have to learn the circuit diagram using basic gates, then you have to learn the circuit diagram using universal gates, and the application of the universal gates, and few more circuit diagrams, and after that we will discuss all the Boolean laws and their properties. Okay, so now children, till now if you have any issues you can tell. Okay, now I am going to post the attendance link. So now I am just providing you the link on your chat box, so please fill that. If you have still any doubt, you can wait. So children, just write some expressions your own and practice the circuit diagram related with the basic gates. Got it? So circuit diagram is simple, like just you have to connect whatever minterm or maxterm is given. Okay, yes. But a minterm is a multiplication of the literals and it is used with SOP expressions. And maxterm is the summation of all the literals and it is used in POS expressions. And I told you that POS expression is the complement of SOP. Just wait, nobody will move, leave. One thing I would like to tell you, that is uh, children, suppose I am just writing one expression here which is a SOP expression, and here it is A complement B plus A complement B complement. Okay, so what is now this expression can be written as like you can write as cardinal expression also, which is Z is equals to function. Z is equals to actually function with two variables A comma B is equals to, here we can write sigma, but children sigma symbol is not there, so I am just writing sigma, and it is within bracket 1 comma 0. This is written as 1 comma 0. The first one is SOP expression and the second expression is cardinal expression. So here the expression, the symbol for sigma is this one. So it will be 1 comma 0. And then what is the POS form? Its POS will be what? Children, here we have covered 1 comma 0 and what are the values which are left? The values which are left are pi 2 comma 3. POS we can represent using pi and summation we can represent using sigma. And now what will be the expression? If it is 2, normally the representation is 1 comma 0 and 1 comma 1. So here in POS you can write a complement, just wait. In POS you can write a complement plus b and this will be in brackets. And here you can write a plus b. Sorry, you can write a complement plus b complement. You can write this. So children, this is the POS expression. And here you can see both are the complement of each other. Here 1 comma 0. So if 1 and 0 we have used with SOP, we will not be using 1 and 0 with POS. So further using Boolean laws also I will tell you how to convert any expression, SOP expression to POS form. Yes. Beta, it is A, so it is 0 and it is 1. So what is the decimal equivalent value of 0 and 1? That is 1. And here if it is 0 comma 0, so the decimal equivalent is 0. That's why it is 0. So you need to find out the decimal equivalent of the binary representations. Pi means POS. Pi means product of sums. Pi means products and sigma means summation. And here 2 comma 3 are nothing but these are the max terms, and here 0 comma 1 are nothing but these are the min terms. So product of the max terms and summation of the min terms. Any query, then please tell. Yes beta. Beta, pardon. A complement plus B. Actually here it is if you write 2, beta, if you write represent 2 in binary, it is 1 0, right? So in POS, A1 can be represented as A complement and this can be represented as B. So A complement plus B because it is the summation of the literals. If it is 1 1 which is 3, so it is A complement plus B complement. But I will explain, I will give you some more examples, don't worry. But not today. So now all of you please fill the form, fill the attendance, and if you have any doubt, then you can ask, otherwise please leave. Thank you. God, God bless you. Bye bye.